Okay, so what approach would you take here to graph this line? Get y by itself. All right, so you're going to divide both sides by -4. All right, so we're going to divide both sides by -4. I'm going to go ahead and rewrite this over. This side's easy. -4 divided by -4 is 1. 1 times y is y. Now, do you remember what we discussed about this side? Right, so write this as two separate fractions. So you're going to say 3x divided by -4 minus 8 divided by -4. That's what we discussed. Okay? Now, you also have to remember that a positive divided by negative is a negative. You also have to remember that a negative divided by negative is a positive. So you want to rewrite this. So you're going to rewrite this as y equals a -3/4 x plus 2. So -8 divided by -4 is a positive 2. All right, so I have this now. Okay, now what are you going to do? Use a t-table. And am I going to use just any value for x? No. I'm just going to use numbers that are divisible by 4. Very good. Divisible by the denominator. So what's the easiest number to always use? 0. So if x is 0, I get y equals -3/4 times 0 plus 2. What's 3/4 times 0? And 0 plus 2 is 2. So I have the point 0, 2. Remember, these are solutions that I'm graphing, or that I'm finding. All right, what other number do you want to use? All right, so if x is 4, I get y equals a -3/4 times 4 plus 2. So remember, you have multiplication and addition. According to the order of operations, you do multiplication first. So if I do multiplication first, I got to figure out what -3/4 times 4 divided by 1 is. You can reduce first, or you can multiply first. It does not matter. If you multiply first, you say -3 times 4, 4 times 1, and so you get -3. So that's -3 right here. But what's -3 plus 2? -3 plus 2 is -1. -1, not -5. -1. All right. What are the number? -4. Okay. If x is -4, I get y equal -3/4 times a -4 plus 2. You do the multiplication first. -3/4 times a -4 over 1. Let's reduce this time. See here, we multiplied first and then reduce. Let's reduce first and then multiply. 4 to 4 is 1. 4 to -4 is -1. Okay, now I'm going to multiply. What's -3 times a -1? Positive 3. 1 times 1 is, so what do I get? 3. So this becomes 3 plus 2, which is 5. All right, so then you plot those 3 points. Go ahead and okay, so we're going to plot those 3 points. 0, 2. Remember, you started the origin. And for 0, 2, I started the origin. X is 0, so I stay, right?
Yes.
Y is 2, so what do I do? Go up 2. So there's the point, 0, 2. If it says label, is this what I mean by labeling? No. All you did was plotted the point. Labeling means you got to say 0, 2 in parentheses. What was the other point?
4, -1.
All right. So I started the origin. I go where?
Right.
Right 4, and then
Down 1.
down 1. So 4, -1. And then the other one is -4, 5. So I go to the left 4, up 5. And so there's the point, -4, 5. Okay, so then you graph that line. Remember, you got to extend it. You must extend. And then what else must you draw? The arrows. And so that's the line. Negative 4y equal 3x minus 8. Or you could have just said y equals negative 3/4 x plus 2. Right, so that's that line. All right? So that's some of the stuff that we did last class period. Now what we're going to do this class period is talk about graphing lines using intercepts. Using intercepts. And we did talk about intercepts last class period. So in your notes, go back to your notes. So you're going to remember that one of the things we talked about is that if I have this line that crosses this axis right here, this y-axis, this point that I'm bubbling in or plotting is called what? The y-intercept. Okay? Now, look at what I just plotted. If I ask you to label that point, what is it? 0, 6. Not 6, 0. Where's 6, 0 located? On the x-axis. That's where 6, 0 is located. This is 0, 6. And we saw that no matter where I drew this line, wherever it crossed the y-axis, remember, wherever it crosses the y-axis, that's called the y-intercept, right? No matter where it crossed the y-axis, the x-coordinate was always what? 0. That's what we saw. And then we saw the same thing with the x-axis. So if I look at these lines, in particular where it crosses the x-axis, where it crosses the x-axis, these lines, these points are called the X Intercepts. Those are X Intercepts. But if you look at this point right here, what are the coordinates of this point right here?
0.
Say it again?
Negative 6.
Negative 6, 0. This one is
3, 0.
3, 0, and this one is
8.
8, 0. So in particular, when you look at x-intercepts, what do you notice about the y-coordinate? Y-coordinate is 0. And when you look at the y-intercepts, you notice that the x-coordinates are 0. All right, so one of the things that you saw that we talked about in the last class period was this. Remember this? So the x-intercept, that's the point where the graph crosses the x-axis. The y-intercept is a point where the graph crosses the that should be what? The y-axis, right? And then the y-intercept, remember that's where I kind of had to reduce some things. The y-intercept, what do you notice about the x-coordinate? 0. The x-intercept, the y-coordinate is 0. All right? Okay, we're going to use that information. All right, so watch how we're going to use this. All right, so directions are going to say this. Directions going to say graph each linear equation. Graph each linear equation using intercepts. Graph each linear equation using intercepts. Number 1. Number 1, suppose we had this. Negative 3x plus 2y equal negative 6. So negative 3x plus 2y equal negative 6. It's also going to state the intercept as an ordered pair. So write the intercept as an ordered pair. So I was going to say X intercept with a blank, and then Y intercept with a blank. All right. Okay, so let's remember about X intercepts. What do you notice about every X intercept? The Y coordinate is 0. So if I want to find the X intercept, I'm going to let Y equal 0. So if I let Y equal 0, wherever you see the variable Y in my equation, what do I substitute? 0. So I get negative 3x plus 2 times 0 equal negative 6, right? And you could have skipped that 2 times 0 because you notice that term 2y is 0, right? So it kind of disappears. And so what equation is left? If you look at it right here, what equation do you see that's left? Negative 3x equal negative 6. And it is true because 2 times 0 is what? 0. So that's 0 right here. 0 plus any term is that term. So that's negative 3x equal negative 6. Now remember we talked about the word coefficient. So what's the coefficient of x here? Negative 3. So to get x by itself, meaning I want this to be the coefficient to be a 1, I have to divide both sides by that coefficient. So I divide both sides by negative 3. And negative 3 divided by negative 3 is 1. 1 times x is x. So what's my x-intercept? 2. So your x-intercept, the x-intercept is 2. But it does say write as an ordered pair. So just don't put 2 here. You didn't follow directions. Direction says write as an ordered pair. So an ordered pair means x comma y. So what's x? 2 comma what's y? 0. That's what we did. Remember we let y equal 0. So that's your x-intercept as an ordered pair. If it didn't say anything about an ordered pair, then you could have just said x-intercept is what number? 2. You could just said 2. But since it did say an ordered pair, you have to say 2, 0. All right, using that same idea, what do you remember about every y-intercept? X is 0. So if you want to find the y-intercept, you let x equal 0. And you do the same thing. So if x is 0, I get negative 3 times what? 0, which is 0. So really all you have left is what equation? 2y equal negative 6. But if you want to write it out, you can. So you'd say negative 3 times 0 plus 2y equal negative 6. Negative 3 times 0 is 0. And 0 plus 2y is 2y equal negative 6. But remember, you got to get y by itself. So right now, multiplying y by, what am I multiplying y by? 2. What's the opposite of multiplying by 2? Dividing by 2. So if I want to get y by itself, if I want the coefficient of y to be 1, then I would have to divide both sides by the coefficient, which is 2. And it kind of makes sense because 2 divided by 2 is 1. That's what I wanted. 1 times y is y. So what's the y-intercept? Negative 3. If it didn't say anything about writing an ordered pair, then what number could you put in the blank? Negative 3. But it did say an ordered pair. So what must you put in that blank? 0, negative 3. All right, make sure you put 0 in the right place. All right, and so then you just plot those 2 points. Remember, no other point, x and y-intercept only. You plot those 2 points. So the first one is 2, 0. So 2, 0 is right here. That's 2, 0. And the other point is 0, negative 3. And so 0, negative 3 is 0. So negative 3 is here. And then notice there's the x-intercept, there's the y-intercept, and you draw your line, and you're done. Just make sure you follow directions. So that's all you do. Okay? So that was the equation. Negative 3x plus 2y equal negative 6. All right. So let's look at the next one, number 2. So for number 2, let's suppose we had this. We had x plus 2y equal 6. X plus 2y equals 6. And again, follow directions. Directions says graph each linear equation using intercepts. Now, first of all, remembering something from last class period, how do you know that those are linear equations? How do you know they're linear? Because if you look at the variables, both x and y, what are the exponents for both? 1. X to the first, y to the first. So you're dealing with linear equations. So when you graph them, you'll get a line. All right, so again, you want to use the intercepts. So you're going to say X intercept blank, Y intercept blank. Okay, to find the X intercept, what do you need to do? Let y equal 0. And it's easy to deal with. All you do is just cover the term 2y. Because if y is 0, what's 2 times 0? 0. So if you just cover that part up, what equation do you see that's left? X equals 6. So you see x equals 6, so that's your x-intercept. X is already by itself. But if you need to write it out, you can. You'd say x plus 2 times 0 equals 6. 2 times 0 is 0. X plus 0 is still, x plus 0 is what? X. So x equal 6. So that's your x-intercept. Again, if it didn't say anything about an ordered pair, then you could just say 6. But it did say an ordered pair, so you got to say parentheses 6, comma 0. Remember, y is 0, so that you put 0 in for y. And then the y-intercept, how do you find the y-intercept? You let x be 0, and you can do the same thing. You can just say, well, if x is 0, that means this term is 0, so what equation is left? 2y equals 6, and you just get y by itself. So y would be 3. But if you want to do the work just like we did here, you can. Wherever you see the variable x, you plug in 0.
Didn't we just do that backwards?
What now?
Didn't we just do that backwards?
What do you mean?
You said 0 for y.
Yeah, because I'm finding the x-intercept. Right? To find the y-intercept, you let x be 0.
Okay.
Isn't that what we just...
Yes, that's what you said.
Okay. All right. All right, to find the x-intercept, so to find the y-intercept, remember, no matter where the graph crosses the y-axis, we notice that x was always what? 0. So you let x be 0. So if x is 0, I get 0 plus 2y equals 6. And what's 0 plus 2y? 2y. And then how do you get y by itself? Divide both sides by 2. Coefficient. Don't say divide by 2y. That's mathematically incorrect. You divide by 2. And then 2 divided by 2 is 1. 1 times y is y equal 3. So as an ordered pair, what is your y-intercept? 0, comma 3. And so then I plot those points and then draw the line. So 0, 6, 0. Remember that the x-intercept is where the graph crosses the x-axis, so that point better be on the x-axis. So 6, 0 is right here. Remember, you start the origin, you go to the right 6. Since y is 0, you stay. So there's the 0.60. That's your x-intercept. The y-intercept is 0.3. So since x is 0, you stay there. Y is 3, you go up 3. So there's your y-intercept. So that's 0, 3. And then you use your ruler, you draw the line. All right. Okay, now, one of the things in my math lab is going to look like this. In my math lab, it's going to be number 3. You have y equals 3x. Sorry, y equals 3x. Y equals 3x. Okay, so I want to graph this line using intercept. So we got to find the x-intercept, the y-intercept. So x-intercept, y-intercept. All right. Now remember, to graph a line, you need at least how many points?
3.
Well, you need at least what? 2. Last class period we saw we did 3 to make sure they were all on the same line, right? Okay. So let's kind of remember that idea here about you need at least 2 points. So when I do the x-intercept, I let what? Y equals 0. All right. So I get 0 equals what? 3x. Y'all agree? Now how do I get x by itself? Yeah, divide by 3. So notice what happens. 0 divided by 3 is 0. 3 divided by 3 is, to answer the question, 3 divided by 3 is 1. 1 times x is x. So my x-intercept is 0, right? As an ordered pair, what is that? 0, 0. Where's 0, 0? At the, what's that word? At the origin. 0, 0 is at the origin. All right, let's look at the y-intercept. To find the y-intercept, you let x equals 0. And so when I let x be 0, I get y equals 3 times what? 3 times 0. But what's 3 times 0? So I get y equal 0. So as an ordered pair, what is that? 0, 0, which is also the origin. So what do you notice about these, about the x-intercept and the y-intercept? They're the same point. So if I plot that point, I get this. That's the origin. That's 0, 0, right? There's an infinite number of lines that goes through one point. But you're trying to graph this line. To graph a line, you need how many points? You need 2. To graph a line, you need 2 points. So in my math lab, you're going to see one like this, and then it's going to say this. If the x and y-intercept is the same, then find one other point. Find one other point. So basically what you would do is this. You'd say, all right, well, that's not enough to graph this line, right? See, in the previous 2, you had the x and the y-intercepts were distinct. They were different. Here, the x and the y-intercept are the same. Now we're going to come back and talk about why they were the same in a little while. But on my math lab, you're going to have one like this. Since the x and y-intercept are the same, and the only way they can be the same is if it's the origin, by the way. And it is the origin. So you need one more point. So you just use a t-table this time, and you just let x be whatever number you want. So give me a number for x.
1.
1. So if x is 1, I get y equals 3 times 1, which is what? So you found the other point that you needed. So 1, 3. 1, 3 is here. And then you draw the line. If someone wanted to use -2, could they have used -2? Yeah. What's 3 times -2? negative 6, and negative 2, negative 6 better lie in that same line, right? And it does. Look, negative 2, negative 6 is right here. And notice when I draw that line, all these points lie in the same line. So in my math lab, you are going to have one of the problems where the x and y intercepts are the same. In the directions, we'll say if the intercepts are the same, use one extra point. And you just do what we just did. All right, now let's talk about why were the x and y intercepts the same. So if I look at this one right here, this equation was x plus 2y equals 6, and this one is y equals 3x, and the one before that is negative 3x plus 2y equals negative 6, and the one before that you can see the x and y intercepts here. It's this as well. What do you notice about these three in comparison to this one, where the x and y intercepts are the same, where the graph crossed the x-axis and the y-axis at the origin? What do you notice is different? Yeah, what's?
The y's have coefficients greater than 1?
Nope, that's not y, but good suggestion. That's not y though.
There's no additional
No additional what?
number, but it's
Constant.
Yeah, that.
Constant. Notice, do you see a constant here? You see two terms, right? Those terms have variables in it. How many terms do you see here? 3. Variable term, variable term. If there's no variable, what's that called? A constant. A constant. So whenever you have a constant, you are going to have distinct x and y intercepts. Notice you see a constant. What's my constant here? Negative 6. Distinct intercepts. What's my constant here? 6. Distinct intercepts. Notice you don't see a constant. Now, you can put one. That constant is going to be 0, though. All right, so that's why. I mean, it's going to be 0. You can say y equals 3x plus 0. All right? But that's why the intercepts are the same and is the origin, because you don't have a constant. Now, if this was 3x plus 5, would the intercepts be different? Yes. It would be different. Okay? All right, so there's one in the math lab, and I think there is one in the worksheet that goes with this one as well. No, there's not. But it is on my math lab, so just keep that in mind when you do my math lab. All right, let's look at this one. This number 4. Number 4, you have y equals 2x minus 8. Y equals 2x minus 8. Now, first of all, are the x and y intercepts going to be at the origin? No, because you have a constant there. The constant's negative 8. It's not 0. Constant's negative 8. So again, you want to use you don't want to use the t-table. You want to use the intercepts. You can say x-intercept blank, y-intercept blank. To find the x-intercept, what do? Let y be 0. Now, if y is 0, wherever I see the y, plug in 0, right? So I get 0 equals 2x minus 8. Y'all agree with that? Now, think about previous courses. How do you solve for the variable x? Get x by itself, so what's your process? Add 8 to both sides. And what's 0 plus 8? 8. Combine like terms, I get 2x. A negative 8 plus 8 is 0, so you get just 2x, right? And then finally, what's the next step? Divide both sides by 2. And I found my X intercept. Where will the graph cross the x-axis? At what number? 4. So as an ordered pair, though, it's 4 comma 0 as an ordered pair. All right, to find the y-intercept, you let x equals 0. So when x is 0, I get y equals 2 times 0 minus 8. But you already knew that was going to be 0, so this term goes away. So when you cover it up, all you see that's left is y equals what? Negative 8. So y equals negative 8. So you found your y-intercept. So the graph's going to cross the y-axis at negative 8. As an ordered pair, how do you write it?
0 comma negative 8.
0 comma negative 8. And then you plot those points. Plot those points. All right, so 4, 0 is here. 0, negative 8 is on the y-axis, negative y-axis. And then use a ruler, draw your line. And this is what you get. All right, so that's the line y equals 2x minus 8. Let's look at number 5. All right, so for number 5, let's look at this one. All right, number 5, suppose you had y equals negative 4x plus 6. Y equals negative 4x plus 6. All right, so again, you want to find the x-intercept, and you want to find the y-intercept. I'm going to go ahead and find the y-intercept first. It's easier to do for this one. So to find the y-intercept, you're going to let x equals 0. So if I cover up the term that has x in it, what do you see that's left? Y equals 6. So your y-intercept would be 6. But if you want to substitute the 0, you can. You would say y equals negative 4 times 0 plus 6. Negative 4 times 0 is 0. And 0 plus 6 is 6. So your y-intercept is 6. So as an ordered pair, it's 0, 6. All right, for the x-intercept, you got to let y equals 0. Now, if y is 0, now be a little bit careful with covering things up because you may get a little confused. Because remember, when I cover up this term, what you saw was y equals 6. If I cover up this term, then you may say, well, I don't see anything. What do I write? Well, you're going to say negative 4x plus 6 equal what? What does it equal?
Negative 6.
Negative 4x plus 6 equal what? 0. Because that's what y was, right? So sometimes you may not want to cover it up like I'm doing. You may actually want to write out wherever you see the y, what do you plug in? 0. So notice y is now what?
0.
0. So I get 0 equals negative 4x plus 6. So that's what I get. So that's your equation. Now, how do you get x by itself? What's the first thing you're going to do? All right, you could subtract both sides. You could subtract 6 from both sides. You could do that. So you would say minus 6 minus 6. What's 0 and a negative 6? All right, I'm combining my terms. So 0, negative 6, negative 6. 6 and a negative 6 is 0. But what's left?
Negative 4x.
All right, but then I got to divide both sides by negative 4. I'm going to go ahead and rewrite this over. But remember, a negative divided by negative is a positive. So this is 1. Negative 4 divided by negative 4 is 1. 1 times x is x. A negative divided by negative is a positive. 6 divided by 4 reduced is 3/2, which is 1.5. So rewriting it as a mixed number is going to help you. Write as a mixed number will help with.
Do we have to?
No, but you better know where 3/2 is in the plane.
Yeah.
You understand? So if I ask you to locate 3/2, if I ask you to locate, so this is 3/2 0, right? So if I asked you to locate that x-intercept, how would you determine where 3/2 is? You first of all need to do what? Write it as a mixed number. Because 3/2 is actually what mixed number? 1.5. So then you could say, all right, I need to go 1 unit and then a what? A half. So there is, right here, is your x-intercept. All right, so be careful with fractions.
So when you write it on there, do you prefer it to
It-
be, it doesn't matter?
No, what she's asking is, do you want to write it as 3/2 or can you write it as 1.5? It does not matter. So right here, you could have said 1.5, comma 0. Does not matter. Okay? All right. But remember, if you do have an improper fraction, you better know what it means in terms of units. So if you have, let's say, I'm making this up. Let's say it's 8/3. Well, you better figure out how many units I have to go. So if it's 8/3, how many units is that? How many whole units? 2, because you know that 8/3 from a previous course. This is what kind of fraction? Proper, improper? Improper. That's an improper fraction. All improper fractions can be written as a mixed number. So to do that, you say 3 into 8, right? So 3 goes into 8 how many times? 2. 2 times 3 is 6. Remainder of 2. So as a mixed number, this is your whole number right here. So that's 2 and then 2/3. 2 into 2/3. So then you would go 2 units and then 2/3 more. And that will be your intercept. All right, just remember that. All right. And then the other point was the Y-intercept, so that's 0.06, so that's here. And this was 1.5, 0. All right. And then you just graph your line and you're done. So there on the worksheet there is a problem that's going to be a fraction. So just remember how to do this. So one of your intercepts will be a mixed number. All right, and now finally, let's look at this. This is going to be a little bit more challenging for some of you. So this is number 6. Okay, number 6. All right, suppose we had y equals negative 3/4 x plus 3. Y equals negative 3/4 x plus 3. So you're going to see one in the worksheet. So when you do the one in the worksheet, make sure you look at the work that's here. And there is one in my math lab as well. So when you do my math lab, make sure you have everything in front of you that you need. All right, so you want to do this. Now, using the t-table is easy for this one, right? So in the t-table, you let x be 0, you let x be what? 4, negative 4, or you could say 8, negative 8, and so on. So using a t-table is easy for this one. But that's not what you're asked to do. You're asked to use intercepts. So let's do that. So X intercept, Y intercept. Now here's what some people do. Some people say, oh, I don't want to use intercepts here. It's easy to use a t-table. Using a t-table will give me credit. No, I will not, because you did not follow directions. Okay? I know. Follow directions. The Y-intercept is going to be the easy one to find here. So let's do the Y-intercept first. To find the Y-intercept, you let x equals 0. So if x is 0, I get this. I get y equals, Yeah, 3. So you could just cover that one up because when I covered up, that the thumb here stands for 0, right? So y equals 0 plus 3, which is just 3. But if you want to write out, you can. So that's negative 3/4 times 0 plus 3. Negative 3/4 times 0 is 0. 0 plus 3 is 3. So you found your y-intercept. That's the easy one. So 0, 3. All right, now let's talk about the x-intercept. To find the x-intercept, you're going to let y equals 0. You're going to let y equals 0. Well, when you let y equals 0, what equation are you going to write when y is 0? 0 equal, because remember y is 0, so this is 0 right here, right? So 0 equals plus 3, so that's where I'm at. So somehow I've got to get x by itself. Now in the previous problem, that one was easy. In the previous problem, that kind of looked like this. It was this one here. Remember this one? Right here? That was easy to deal with because you didn't see any fractions, right? Here you have a fraction for the coefficient. So let's think about the best approach to take here. So just like the previous one, if you compare, when I had this, what was the first thing I did? Subtract, well, here in the previous one, I subtracted 6, right? So here I'm going to do what? Subtract 3. All right, so subtract 3 from both sides. So 0 and a negative 3 is a negative 3 equal negative 3/4 x. All right, now what I would do here is I would break this down into 2 steps. You see right here, negative 3/4 x means the same thing as negative 3x divided by 4. Do y'all agree with that? Okay. So if you look at this, I'm dividing by 4, right? What's the opposite of dividing by 4? All right. So what I'm going to do is I'm going to rewrite this over. And I'm going to multiply both sides by 4. Because right now I'm doing what? Dividing by 4. What's the opposite of dividing by 4? Multiplying by 4. And then notice what happens. What's 4 times a negative 3? Negative 12 equal. Now, you can reduce or you can multiply first. Remember? So if I multiply, I want you to think about this. This right here. If you pull that off to the side and kind of look at it. Right here, this is this. What is 4 times a negative 3? And what's 1 times 4?
4.
What does that become?
3. Negative 3.
Negative 3. You kind of knew it had to be negative 3. You kind of knew it had to be negative 3. Because if I multiply by 4, these reduce out, right? What's left? Negative 3. So 4 times a negative 3/4 x is a negative 3x. And then, then doing what?
Doing it just the other way where you flip it.
Okay, so I'll do that one as well to show you. All right, so that's one approach, is to do it this way, and then I'll explain what she's talking about. Okay, so then the next step is to do what?
Divide.
By negative 3. And then if I reduce, negative 3 divided by negative 3 is 1. 1 times x is x. And then negative 12 divided by negative 3 is
4.
4. So there's your x-intercept. So my x-intercept is 4, 0. Now this is what Angela is talking about. So I'm going to go back and I'm gonna rewrite this step right here. This step right here. I'm going to go ahead and rewrite it. And say, or you could have done this. So negative 3 equals negative 3/4 times x, right? One of the things that you learned about in a previous course is this. If I have 2/3 divided by 4/5. 2/3 divided by 4/5. How do you divide those two fractions? What did y'all do in a previous course? Has nothing to do with finding a common denominator. The only time you find a common denominator or the least common denominator is when you add or subtract. Whenever you divide fractions, see how a lot of you forgot, right? Okay,
You gotta flip it, huh?
that's right. You got to change the multiplication problem. I am dividing. Whenever you divide fractions, one of the things that you learned 2 semesters ago, if you took it, or you learned during your first week of birth, was this. You take the you take the top fraction, multiply by the reciprocal of the bottom fraction. Now Angela finds that easier than what we just did. It's up to you.
It's easier.
For Angela, it's easier. All right, so you're going to say 2/3 times what? 5/4. And then you would either reduce first or multiply. Here you can't reduce anything, so you just multiply.
You can reduce
2 times.
2 and 4.
Oh, you can, yes. So 2 to 2 is 1, 2 to 4 is 2, so you get 5/6. Okay? All right. So that's something you have to use in order to do this one, though. So this is what she did. She said this, well, I am multiplying x by -3/4. So the coefficient of x is what?
1.
The coefficient of x is what? -3/4. Right now, multiply by -3/4. So what's the opposite? Divide by -3/4. And the -3/4 divided by -3/4 is 1. 1 times x is x. And this right here is this.
It just makes it one step.
It's okay. Whatever you want to use. But I'll tell you this is a good idea to know as many possible ways as possible. The more tools you have in your mind, the easier it is for you to progress through these courses. So even though she prefers this way, I'm hoping you know what I did here. The more tools you have, the easier it is for you to progress through your courses. Okay, over here, I have -3 divided by -3/4, correct? All right, let's remember what we just did. When I divide fractions, notice that division right here. When I divide fractions, I change this to a multiplication problem. It's the numerator divided by the reciprocal of the denominator. Okay. Here's my division. I got to change it to what kind of problem? Multiplication. The numerator, which is -3 divided by 1, times the reciprocal of the denominator, which is -4/3. Good. And then we could multiply first and then reduce. What's -3 times -4? What's 1 times 3? What do I get? 4. Okay, which is what we saw. So it does not matter which approach you take. Does not matter. It's up to you. Okay? So there are some things that you may have to go back and review. For some of you, if you can't remember, this, what I just did, go online and Google dividing fractions. And you'll get some videos on dividing fractions. This is what you're going to see. So real quick, if I had this, if I had -8 equal 2/5 x. Let's say -2/5 x. And let's do positive 8. Positive 8. And let's do it the Angela approach. So what are you going to do? What are you going to do to both sides? Divide both sides by -2/5. Okay, all right, so I'm going to rewrite this over. Oops, I keep putting negative. I'm going to rewrite this over. I'm going to say divide by -2/5, divide by -2/5. Okay? And remember, the whole idea is to get x by itself, right? And I am because I know that -2/5 divided by -2/5 is what number? 1. 1 times x is x. Now I've got to remember something from a while back. I'm dividing fractions. So I got to change this right here to a multiplication. So it's the numerator, which is 8 or 8 over 1, times the reciprocal of the denominator, which is
Negative 5 over 2.
-5 over 2. And then if you can reduce, reduce first. If you don't want to reduce first, you don't have to.
4 and 1.
Yeah, if you reduce, it'll be 2 to 2 is 1, 2 to 4 is, I'm sorry, 2 to 8 is
4.
4. 4 times -5 is
Negative 20.
-20. 1 times 1 is 1, and that gives you
Negative 20.
-20. So that means that x is
Negative
-20. Right, that's all you do. All right. The other approach, just the one that we did, is this. It's up to you. So remember, right now I'm dividing by 5. What's the opposite of dividing by 5?
Okay.
Multiplying by 5. You agree? What's 5 times 8?
40.
The 5s divide out. What are you left with?
2.
No.
2x. Negative 2x.
Negative 2x. And then finally do what?
Divide by 2.
Nope.
Negative 2.
Negative 2. And you got your answer. What's x?
Negative 20.
-20. It's up to you which one you do. Does not matter. Say it again. You got it? Alright. Do you see that it does not matter, right? Some of you, I would imagine that most of you probably prefer this one. And then some of you might prefer this one. It's up to you. You get the same answer. Alright? Okay, so let me go ahead and do this.